Hi, welcome to Mythbusters, Distance Education Edition.
Today we're going to look at some of the most popular and widely held myths about games and entertainment-based educational practices.
So remember to take all necessary safety precautions and don't try this at home.
Wait, I thought that we wanted them to do this stuff.
Oh yeah.
What's the first thing that you hear when talking to teachers or instructional designers about using games in their educational practices?
Well, provided that they don't have some of the negative biases towards games, the biggest thing that I hear is that it takes too long and it's too hard to create games.
Well, that's actually two myths, right? There's the fact that games take too long to develop, and then there's the part where games are too hard to create. So why don't we look at those one at a time and first look at games being too hard to make.
All right, let's get started.
On this episode of Mythbusters, there's the good,
14 seconds,
the bad, and the downright bizarre.
That's insane!
So thinking about what we needed to do to get this all running is that we had 2 months to make this happen, and there were 4 people on the team. And all of us have full-time jobs, and we're full-time students, and we still had our regular 860 obligations, and ultimately we were looking to turn out 3 complete game-based activities from scratch, and then package it all up in a way that people can interact with it.
So that was a pretty tight schedule. I imagine there are things that didn't work out the way people wanted.
Well, some of the decision making on some of the authoring tools took a little bit of time, and sometimes some of the scripting took a little bit of time, and I know to illustrate things it takes, so there were some time constraints in me being able to get, all of the content in on appropriate time.
Yeah, I think we were worried about getting it all done, and that, I think, kept us from starting. Like, thinking, will we have enough time to get it done, and planning so we could have enough time to get it done, and not starting.
Hamsters running before the... Yeah.
And I think testing was an issue too, getting everything done and completed in time for us to test it to make sure everything worked.
Yes,
that
testing
was
also
difficult.
But each of the individual pieces didn't seem like they took too long to complete, right?
Yeah, no, they didn't. But one of the things that ended up happening for me was I had to do a lot of cuts. Like if you found the secret file of my game commentary, I had some other ideas about additional interactions and additional little mini games within my game. And as I got close to the date, I just started to cut interactions and cut interactivity to make sure that we were able to release on time with a product that actually worked.
Simplify.
Yeah, we just simplify our initial vision. So with all that said, given all the time constraints, I think we were pretty proud of what we created though.
Absolutely.
Yeah, I mean, we got it done. And it wasn't like we didn't complete it, right?
So with the time constraints, I'm going to say busted.
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 Busted. So they passed off that second myth to us, that it was too hard to create some kind of game, right?
The reality was it wasn't that bad of a deal. We ended up using Articulate, and it turns out that was one of the more simpler programs, and I used a lot of traditional illustration and a little bit of Photoshop, and these are widely accessible.
Yeah, and there wasn't anything that kept us from being able to make it. I mean, it was almost easier than we expected, and I think the hardest thing was waiting that time to determine what we were going to use.
Yeah, basically. I think we worried a lot about what we were going to use, and that wasn't what the problem was. I think we just had to go, and the application fell into place pretty quickly.
Yeah, and we didn't have to buy anything. We didn't have to spend thousands of dollars. I mean, I know Dr. Beatty actually made a real good point about deep pockets, making it difficult to create things, and we didn't have to buy anything. It was all freeware or trial versions, so it wasn't hard at all.
Yeah, and just to say that I was trained in illustration, so I used my own illustration skills, but a lot of these images could be available, online, royalty free. We just chose to do that because that made the content a bit more, specific to our situation.
Right. I mean, you went old school illustration, so it wasn't like we were using, Illustrator and trying, and using a light pen or anything like that and trying to
Yeah, all it took was a pen and a pencil and some Photoshop.
So I don't think it was that hard. You?
No, it was actually really simple.
Easy. So, busted?
Busted.
Okay, so creating an interactive story wasn't too difficult, but what about making a scavenger hunt using a relatively new and somewhat untested application, Scavenger?
So this one might be a little bit harder to bust because the scavenger hunt in itself was really easy to create, but we struggled with, could we really require people to go out on a scavenger hunt around the city?
You're right. It's important for this one that we needed to make sure that it was available to people who couldn't make it around the city, but we also wanted to make some incentive for people to go out and win and visit the actual locations.
So that posed a bit of a problem with so many people using this application with different platforms in different ways. Usability testing was really hard.
But I think that with the exception of one person, everybody who attempted it was able to eventually access all the treks and answer the questions.
Yeah, I think so. So you're right, everybody was able to participate in some way. So I think this one is...
I think busted.
Busted.
So I figured that I would give everyone a look inside of Unity, the game development kit that I used to build the Lost game with LERPs in it. I think a lot of people who haven't done programming kind of have this idea that programmers sit in front of a screen of text and pound out lines of code to write programs. And it's true that some people do that, but actually most of the software development these days is done in what are called development kits, where there's lots of frameworks and other interface builders and lots of things that help you create some of the routine things or some of the things that people do all the time. So games are typically built with an engine which controls interactions, and then usually there's a development kit beyond that helps build sort of the worlds. So Unity's a game development kit for Windows and Macintosh. It's free for the regular version. It's expensive for the pro version with all the extra stuff. And I was going to give you a quick tour around how I built some of this stuff. So as you can see, we get the overview of the island here, and there's a lot of extra little things because there are icons for where my light source is, and it looks a little different from the game because not everything's rendered. And so I can move myself around here and take different perspectives to see where exactly and how to place things. Over here I have my hierarchy. These are actually all of the objects that are in the scene. And so when you go to put things into your scene, which is where people actually play, you can either drag them as objects or various sorts of things. So let me find Lerps, which you can see down here. Lerps was the robot character that you controlled. And let me focus in on Lerps here. And you can see that he's got his little robot. And there's lots of other stuff here. We'll get into some of those things. Now, I didn't animate Lerps. Lerps was provided. It actually takes a really long time to animate characters, and you don't actually do that in the game engine. You use Blender or Maya 3D or Cinema 4D to do things like that. So I actually used Lerps from another project that I was using to learn, so that I wouldn't have to animate a character. So when I dragged Lerps in from my project, because I have Lerps over here, that's sort of my prefab for Lerps, I would drag them in and just drop them in the scene. And then I would add various interactions to it. So for instance, if I go ahead and expand Lerps's thing here, we see that Lerps has his character himself. Lerps's shadow, which is actually a projector. And you can see as I click on different things, I get different things in the inspector, which shows the position and different attributes of it. So the projector actually is just this blob shadow down here. I can move that around independently if I want to, and actually like give him a little bit less of a shadow as it comes down, or more of a shadow, and just kind of set that there. Do that. And then he also has his various parts of his body, which if I expand that, we grab his other parts that are animated separately. And under torso is where you see the little jets, and the jets happen when I click on it. I have different jet things. So like this is the left jet, and then the right jet, and the light is actually something entirely different. I can turn that light off so you can see what it's like without that light being generated. And so each of these things is objects, and I drag them all into the scene. So Lerps himself over here doesn't have all those objects. In fact, if I expand that, you can see that he has just his shadow and the various parts of him. He doesn't have the jetpack, so I had to drag that in separately. But I don't build each of those things. So let me look at this left jetpack and focus in on that. It's using something called a particle emitter, and I use particle emitters in a few different places here. I use it for his jetpack. I use it for, if I grab my spaceship down here, the ship's fire is another particle emitter, and that particle emitter is kind of going crazy right there. But all of these things are built in that I just would go up to component, and I go particles, and I'd add a particle emitter. So no programming at all at that point, and then just changing different values to give it more velocity, more particles, less particles, change the color of it to make it look like fire as opposed to the waterfall, whose particles were, grab the emitter here and then focus in on it. Scoot that around. You can see the particle emitters there. I have the watercolors that actually create the particles there. So no programming at all to sort of build these sorts of things out. You just kind of grab objects of different kinds and then drop them in. Another thing I wanted to call attention to with Lerps over here is you see this green capsule around it. That's a capsule collider. So another thing I wanted to bring attention to is this green capsule you see around Lerps. That's a capsule collider, and so a lot of things, grab it over here. A lot of things in games deal with when you actually run into another object, and so Lerps is controlled by when that capsule hits various objects. So if I look at this data file over here, it also has a capsule collider. Or actually has a sphere collider around it. You can see the green object around. So when those two colliders hit with each other, that's when it tells the scripting to say, okay, pick this object up and then do something with it. Now, I said that there is very little programming. The do something with it is where all the programming happens. And of course, with games, the do something is the most important part. So if I grab this fuel cell again, you can see that I have this pickup script, and the scripting is what controls a lot of the interaction. So I'm going to go over in my scripts file in my library here, my project library, and open up the pickup script. So I opened up a whole bunch of scripts here, and over here, this is my sort of manager and editor for editing the programs, the actual programming part of it. And I opened up a whole bunch of scripts up here so we can look at a few of them. This is the pickup script that's actually attached to that other object. And I use JavaScript for this because I was more familiar, but Unity can also use Boo, which is a Python-based script, and also C#, which is a Java-like scripting language from Microsoft. And so this is where the actual interaction happens. And if you have some programming, you can kind of pick through this. But the big one is here. I want to point out the on trigger enter. So this is a specific interaction that's an API based in Unity that says that when this collider has the collider actually has a trigger, it creates this function to happen. It calls this function to happen. And so a couple things here. It actually loads the third-person status script, which I'll grab third-person status over here. This one's actually attached to lerps and contains really, you know, I have my comment up here, keeps track of inventory, hells, lives. And so it keeps track of all of the attributes of the player during the game. And then it changes the clip number. So each of those files had a clip number, and then it called another function in my audio clip player, which was to switch the clip. And if I grab audio clip player, this is the script that I wrote, and you can see I didn't comment it. The comments are in blue, which is bad programming form, but I was kind of running short on time. So we say switch clip found, and so this actually changes the clip found ID to true. You know, to go, I don't want to get too bogged down in code here, but to go back, you can actually see this happening when I do a quick little playthrough. If I hit play here, and so this is a little testing format, which you can probably recognize. This is the beginning of the game. It's a little jumpy because I'm doing lots of things at once here. And then let me grab lerps so that I have the script information. Oh no, actually I don't want lerps. I want the camera, because the camera is actually what contains a lot of this stuff. And so the camera has this information, and you can see here the clip found array shows that I only have clip 0 that's found, which is the instructions that are given. And then you can watch as I take lerps and walk him over to that clip, and watch what happens when I pick it up with element number 1 there. And so it plays a sound, it destroys that object, and then it changes this over here, and that's all done in the JavaScript. So I want to briefly show where, how you kind of start all this, and how it isn't maybe as daunting as it might seem at first. I'm going to create a new scene, and I'm not going to save because I didn't really want to have any of these changes. And so this is my new scene that I have, nothing in it. The first thing I want to do is I'm going to create a terrain, which is what I would normally do another. And I'm going to go up to the top view and kind of scoot out here, and look at my terrain information, and sort of grab this out here. And then go to my set resolution, and this tells me how big my terrain is. So this is actually all in meters. So my terrain width is 2,000 meters, and my terrain height, max height, is 600 meters. So this is a really huge map. Let me just knock this down a little bit, because this is a little bit ridiculous. Go 500 meters for each of those, and set resolution. And so I'm going to go ahead then, and that's much more reasonable as far as what we have here. And right now it's just this flat sort of thing. So let's go ahead and let's actually make something out of this. And so I'm going to go back to my top view, grab my terrain here, and then grab a brush to set everything at a height. And I'm just going to set everything at a height of 40 meters, because that's kind of a nice level area for ground. And make this big, brush size, make it huge, and just everything at 40 meters. And kind of brush that in there. You can see the edge of where it's getting, where the ground is getting pushed up. But this just gives me a nice starting place so I can build something from there. All right, so it's all set at one height now, and I'm going to go back and I'm going to set this height now to 0, because what I'll do is I'll say 40 is level ground, where I want most things, and then I'm going to set the height to 0 for the other stuff, because I'm going to make an island, because I guess I really like islands, as was shown by the other project that I did. So I just start drawing now for the outline of where this island's going to sort of end up, and I can just sort of draw this around, and I'm just going to make the outline here. And it really is as easy as just, Photoshop, more or less. And I take a couple passes here. Actually, I'm going to increase the opacity so I don't have to go over it like 18 times. And right now, because I'm in top view, it probably doesn't look like a whole lot. I'm going to increase the brush size now again so that I can just knock all this stuff out in a hurry. Looks like I got the edge of a little bit there. It's actually not a very good use of space having such a small island, but oh well. And let's take a look at that and see what that looks like. So grab my tool here, move it around, and you can see now I have an island. Except that it's all just kind of gray, and obviously there's no water. So what I do then to add water is I would go over to my standard assets that are provided with Unity, go grab my basic water, and let's go nighttime simple water. And I'd actually just drag that in there. Now, I need to make this bigger because right now it's 16 meter by 16 meters, and if you remember, I have a 500 by 500 block, so I'm just going to make this at 1,000 by 1,000 just to make sure that we have plenty of space on both sides. And you can see that it's now grown out there. Now my Y value is how high it is. It's at 39. If you remember, I set my ground at 40, so I probably don't want it to be right up there, you know, half a meter lower. So let's make it at just 39 exactly. And you can see that now I have my island. And if I scoot this around a little bit, you can see I have that flat land just above the water level. I can add some, go back to my terrain, and I can add raised terrain, and I can give some sort of hills or mountains here, which unfortunately this is going really fast, so this isn't going to look anything realistic. But you can see that you can just sort of bring this up. I can then paint the terrain with some textures. So I have, let me just throw in a quick little grass texture here. And so since I have my grass and add that, so yeah, now it has grass. And if I want light, I can then bring in a rendering, a light, which we want a directional light for sun, and then pull that up. Oops, nope, that's not what I wanted. I grabbed the terrain there. Actually, that's right. So I added the light to the terrain. I actually don't want to do that because it's going to stick on the terrain. So let me go ahead and click over here. So I'm not selecting the terrain, and then render, get a new component, call that light, and then attach the component of rendering for a light, and then, yeah, I don't want point light, I want directional, and then I can bring this up, bring it back, and then change the angle so that we can see how changing the direction of that light makes it look more or less like direct sunlight, or sort of the nighttime thing. And so as you can see, this is just a couple quick minutes and I already have the beginning of this environment that I could be working in. So thanks for following me through Unity. Hopefully it makes a little bit of sense, and hopefully you enjoyed some of what I was able to show you, and I really do hope that you give it a shot and maybe try and do something with it, because I think it's really powerful for a free product, and you can make some really neat stuff.
So after seeing all that, what do you think now?
Yeah, I don't know. Me personally, I think that all those tools are relatively easy to use, but I have to admit that, to use Unity, you need to know JavaScript, and that's not something that everybody knows. So there is some advanced knowledge needed to complete some of this stuff.
Well, that's fair. I'd say it's easier than people think, but maybe not easy enough for widespread use.
Yeah, so I feel like this myth is mostly busted because I think it is more straightforward and more accessible than people think, but it definitely isn't something that you can just pick up without any sort of effort.
So on to the next myth then?
So yet another myth, right? Tons of them out there. So, this big one, right? Games are not appropriate for education. You can't learn anything from a game.
Well, I mean, I could see for entertainment, but are these appropriate for education?
No, I mean, don't be silly. Games are already being used for education, right? In New York, they're using Quest to Learn, right? And they're using it. It's already been implemented successfully with students, and they're encouraging them to role play and learn through role play as historians or mathematicians, or even create their own games.
Wow, that was 2 good examples. I mean, I'm pretty amazed. I didn't know.
Yeah, and Georgia Tech, right? They're using a game testing series for Glitch. It's Glitch game testers. They're using that to help underserved African American population learn job skills in game testing. So allowing them to go out and get jobs in the game field.
Wow, game testing. Game testing is like out there, and you know, students, it helps them learn about technology.
Yeah. So, you know, they're using it all over. I think busted.
Busted.
Cure.
So our fourth myth is games are not effective for learning.
Well, we were using them for learning. But you know what? We don't need to advocate that, right? We had the opportunity to talk to some experts in the field who are using games for learning.
Cool. So let's go talk to the experts.
Let's see what they say.
So my name's Alicia Sanchez. I'm the game czar at Defense Acquisition University, where I help make decisions about when and where we're going to use games in our curriculum. I got into games probably about 10 years ago. My PhD is in modeling and simulation, and the reason we use technology like simulations for the military, which is what I've been primarily involved with, is because we want people to have experiences that they either can't have because they're too expensive, they don't happen frequently enough, or they're just too dangerous. And games are a great way to supplement simulations to add characteristics that will lead to replay.
My name is Karen Burpee. I work for the Canadian Army as a senior instructional designer. I've been involved in instructional design for a little over 10 years now, and I've been interested in serious games and games for learning probably for the last couple of years, probably 3 or 4 years.
So I think that education is, as I said, is starting to sort of mainstream games, which I think is fantastic. But I think one of the larger limitations that we're seeing is that people have this perception that through games, just in isolation, just any game, that we're going to see greater engagement, greater learning, and, you know, more attentive students, which I don't think is the case. I think that the entertainment industry has a really good way of filtering out good games and bad games. And the games that we've played are the good games, right? They're the cream of the crop, and they really are, you know, the few that made it out of masses of games. In education, we don't have the numbers to be able to really start to sort through those. So a lot of organizations, a lot of, you know, K through 12 places are incorporating games just for the sake of games, in some ways gratuitously, but they're not able to really have that refinement process that the industry of, you know, consumers puts any standard game through. And therefore, we're seeing a lot of crappy games. We're not seeing the best games. We're not getting the best of class in a lot of cases. And the community at large just hasn't really done a great job of sort of refining and getting rid of the ugly babies in this case. And so unfortunately, we're seeing a lot of games that just aren't doing what they're supposed to. And having that kind of experience early on in a game's implementation process or in a project can often turn people off quite quickly. Like, oh, well, we spent a ton of money, we made a game, and it didn't work, and we don't understand why. We're not going to do that again, when really it was a crappy game to start with, and it was doomed from the beginning.
I'm not sure about a major historical turning point, but certainly a curve, if you will, in terms of using games for learning is finding that narrative space. It's not simply a linear, you know, do this, then do this, then do this. It offers learners a chance to work within the larger construct of a game. So maybe we have some story in there, maybe we have some abstract concepts, and we want people to be thinking in terms of, we want people to be thinking critically. So if they figure out that this wonderful learning opportunity that they have is a game, and it's designed to help them learn, then so be it. You know, we have critical thinkers, and that's absolutely essential for the 21st century. I mean, we need critical thinkers. We don't want people who are just, you know, running around like sheep going, well, you know, I can't do that because I don't know. You know, I want to be a leader, but I'm waiting for my leadership course to show up in my LMS. You know, so we need to be fostering these kinds of skills because I think they are being lost, and I think that games can help.
So, our myths, right?
Yeah. So we came up with games take too long, and we completely busted that.
Busted.
Games are too hard to make, and we kind of busted that. Games are not for education is completely busted.
Totally
Completely
busted.
Yep.
And games are not effective for learning is completely busted.
Yeah, completely busted.
So I think that, you know, people who have these sorts of decisions about using games and always come up with excuses not to, I don't think those excuses we found those really to be true.
Yeah, I'd say overall busted, right?
Mm-hmm.
Yep.
Busted.